from the salaried staff in July this year, which proved to be quite a timely moment. While I was at Nottingham, I did various things, including teaching for some years, first year course on the Industrial Revolution. Go to the next slide, please. Sorry, can we go to the first slide, thanks. In any course, in either the history department or in this case, it was actually the Nottingham University Business School, it's usual to devote one session to the impact of the railways on the mid-19th century British economy and afterwards. In explaining railway history to undergraduates without any special knowledge of the subject, it's usually simplest to divide the impact of the railways into two groups of effects. On the one hand, what you tend to call forward linkages, which is simply that the railways lowered transport costs for virtually all industries, and on the other hand, backward linkages. The forward linkages are fairly easy to explain. The railways lowered the assembly cost of raw materials, and for most industries, they lowered the distribution cost of finished products. For some industries, for example, iron and steel, they also lowered intermediate costs because of the transfer of semi-manufactured goods from one stage of production to another. That process of speeding up assembly and distribution lowers inventory costs. And so railways have a beneficial effect in that sense on virtually all industries. Next, please. Next, please. Yeah, the backward linkages come about obviously because the railways are major consumers of large quantities of raw materials. They're also major consumers of capital and labour. You can divide this type of consumption into a number of headings. The three which stand out most obviously perhaps are raw materials that are used both during construction and afterwards. I've given three groups there. There are others. First of all, you have building materials, stone, brick, tile and slate. Bricks in particular were used on an enormous scale by the railways. Then both iron and non-ferrous metals. And the third one there is timber. If you ask undergraduates in the seminar to pick out those sort of raw materials, the ones which they tend to think of, the one which they tend to think of first is iron, because self-evidently railways run on iron, later steel track, and locomotives are built principally of iron, steel, or non-ferrous metals. On one occasion, prompting students a little further, one student said, "What about the sleepers that support the rails?" I said, "Yes, good point." He said, "They're made of concrete, aren't they?" I said, "Well, nowadays they are mostly, yes. Historically, they're made of timber." He said, "So how many sleepers do you need to build a mile of railway?" I said, "I don't actually know offhand." By that time, another student in the class had looked this figure up with the aid of Google and actually came out with a figure for the total number of sleepers on the world's railways today. I said that was probably a figure that should be treated with some caution, but I said I will try and find out, or if not, work out roughly how much timber we used by the railways in Britain, at any rate in the 19th century, before timber began to be superseded by other materials. I didn't, in fact, have time to do it in time to present it to a class, but it was something that interested me, and so that's really it's really the results of that work that I'm presenting this evening. Next slide, please. Obviously, to an audience of railway engineers and other engineers, the next few points will seem very obvious. These slides were ones which I used for a lecture to a lay audience some months ago. Just to run through very quickly the sort of uses to which timber was put, mainly I should say up to the First World War. I could have added as a subtitle to this talk that I'm mainly talking about the period up to 1914, 1918, or the grouping of 1923. But until the First World War, railway carriage bodies were built principally of timber, under frames switched to iron or steel at a rather earlier date. And so you get oak frames, pine or teak cladding to railway carriages, and then the use of small but relatively expensive quantities of hardwoods, decorative hardwood veneers, inside carriages, particularly first-class carriages or special carriages. Next, please. Likewise, on a greater scale but less glamorously, the majority of wagon underframes for at least the first 30 or 40 years of mainline railways were built of timber. Gradually, iron or steel replaced timber in underframes, but the Railway Clearinghouse was still issuing a model drawing for a timber underframe, wagon underframe up to 1923. Next, please. And then the superstructure of wagons was again predominantly timber until well after the First World War. In fact, you have obviously hundreds of thousands of open wagons built, 3, 5, 7 plank wagons using normally 2-inch pine as the planking material. Then the next slide, please. And different kinds of covered wagon, covered van also used timber for panelling, again, usually pine panelling over an oak frame, even if the underframe had switched to channeled steel as a method of construction. Next, please. Stations predominantly in this country were built of brick or stone. In fact, one of the ways in which the railways were criticised in Britain compared with other countries for being overcapitalised is that they built unnecessarily elaborate stations. Some companies did use timber framing, timber cladding for secondary stations, and the example bottom right there is actually from Killermarsh on the Manchester, Sheffield and Lincolnshire Railway, which was regarded by contemporaries as a pioneer of high quality timber frame station buildings. So there is some use of timber, not just for roof timbers, obviously for station buildings, but also in some cases for walls as well. Next slide, please. More commonly, signal boxes were either built entirely of timber framing with timber cladding, or in some cases the ground floor was built of brick or stone, but the cabin itself was built of timber. That's an almost completely new industry. There is no real parallel before the railways arrived for using timber framing for these kind of line-side buildings. The next slide gives some more examples. Then you have other uses of line-side timber, not large quantities in any one case, but cumulatively quite a lot. I've included there examples of a signal post, of line-side fencing, and also the slatted station fencing which some companies used, telegraph poles, of which millions presumably were erected by the railway companies and the post office, and level crossing gates, again another minor use of timber. So in other words, the railways are a large consumer of timber, and by and large these are new uses. Obviously there were fences before the railways were built.
How do you make this full size?
Sorry. Because the railways in Britain were required by law to be lined by fences on both sides, which is not common in other countries, then the railways create a large new market for fencing materials. The next slide, please. Now, those are only a handful of obvious examples. I could have included others. For example, in the early days of mainline railways, timber was used for some bridge building, although it goes out fairly early on. Timber was also used for bridge centering, for tunnel centering in the course of construction. The point about all these uses of timber is they're familiar enough. It's easy enough to describe them, but it's much harder to quantify how much timber was used or where the timber comes from. I've searched the literature in vain for finding trying to discover more, for example, about the supply of signal boxes, which seem to have been supplied mainly to railway companies by the companies that made signals. But where the timber came from, how much they used, I can't as yet find out. And similarly, it's difficult, unless you spend your entire life reading hundreds of volumes of railway company board minutes, to work out how timber got from a forest or from a dockside to the railway. It would be fair to say that the standard railway company history does not devote a great deal about the consumption of any raw materials, and certainly not, I've discovered, of timber. So next slide, please. What I want to concentrate on this evening is one of the uses of timber, possibly the only use, but at the moment it's the only one I can think of, the one use of timber by the railways, which can probably be quantified, at least approximately. And so I'm presenting this as a case study of quantification in economic history. I suspect engineers, people from a science background, sometimes think that historians only work in generalities. In fact, economic history doesn't. Traditionally, economic history does try to quantify things. But you have to, I think, always be very careful with history, not to try and count that which you can't count and produce improbably accurate results. You try and quantify things as precisely as possible and avoid making generalized comments without any statistical basis to them. So this is an example of how historians work in this particular case. So let's move on to railway sleepers specifically, a mundane but essential part of a railway, quite obviously. Next slide, please. So as I say, I think it's probably the one use of timber which can be quantified. I should say in parenthesis that after I prepared and for the first time gave this lecture, I did spend some time looking at, for example, wagon building, carriage building, to try and decide whether you can count how many cubic feet of timber go into a typical open wagon, what proportion of total timber output does that represent. But at the moment, I'm not really satisfied the results mean very much. Sleepers may be the largest, if not the largest, use of timber by the railways. And I thought this does throw up new thoughts about linkages between the railways and the timber industry, which is an industry which expands greatly in the 19th century. And I'm also going to bring in towards the end one downstream industry which is associated with timber through, in fact, principally through the use of timber for railway sleepers. Next slide, please. So if you're trying to measure sleeper consumption, I felt there were 5 variables which you have to try and estimate. I wouldn't necessarily say measure them, but at least estimate them. One is the ratio of route mileage, which is well recorded, to track mileage. Then you need to measure the annual increase in track mileage. You then have to decide how many sleepers per mile were used in the 19th century. What was the average life of a sleeper? And how many cubic feet of timber went into a sleeper. Now, I suspect some of those variables are covered by British standards today, or certainly by custom and practice. They vary a good deal more in the 19th century, so it's not a case of just looking up the latest Network Rail manual on how to lay track. There is a bit more to it. Next slide, please. I'll look at each of those in turn. So route mileage figures have been recorded for the railways from the 1820s. In fact, you can reconstruct figures back to about 1800. But the mileage of multiple tracks was only recorded from 1910, when there was a revision in the way in which railway statistics were collected. That year, just under 20,000 route miles of railway contained just under 35,000 track miles, which is a ratio fairly close to 1 to 1 3/4. The question is, can you project that backwards to the beginning of the mainline railway in the 1830s? Next slide, please. And this illustrates the variations. These are some random figures culled from company histories. It would be possible to collect more, but I suspect the average you end up with won't vary that much. So even by 1850, nearly all the Midland Railway was double track. The London South Western Railway had, as I've said there, just over 1,000 route miles, but 2,500 track miles, so there was rather more single track. The London Brighton South Coast Railway, again, it's a different figure, 450 figures after 1910, include sidings and private branches, or the very large mileage of internal user railways, the collieries, steelworks, some other big companies, which would have used timber sleepers. So what I've taken is an average ratio, which I think is a conservative estimate, of one route mile of track equates to 1 3/4 miles of track mileage. Sorry, stumble there slightly. So in other words, multiply the route mileage by 1.75 to get an estimate of track mileage. Next slide, please. Then there's this question of how many sleepers do you lay per mile. The most commonly quoted figure is to lay them at 3-foot centres, which conveniently means 1,760 sleepers per mile. But if you look at particularly accident reports in the early days of railways, you'll find that some companies were considerably more sparing with their sleepers and laid them at 4 or even 5-foot centres. The Great Central Railway, on the eve of grouping, was using over 2,000 sleepers per mile, which is a good deal more than 1760. And so what I've done to keep the arithmetic simple is to take 2,000 sleepers to the mile as the average. That may apply more to the second half of the period, say after 1870, than the first half. But although I'm not presenting here all the spreadsheet details I worked out, if you move any of these variables up or down a bit, it doesn't actually greatly alter the final figure, which I'll present in a moment. So let's say 2,000 sleepers to a mile as an average. Next slide, please. How long do sleepers last? In this case, again, a considerable variation. There was an inquiry carried out not by one of the British engineering institutions, but by its American counterpart, the American Society of Engineers, in the 1880s. They collected a huge amount of information from British companies, which reveals a considerable variation. The Midland Railway just reckoned that what they called a well-creosoted sleeper lasted over 20 years. the Great Northern quoted half that figure. The Lancashire and Yorkshire said midway in between. The Manchester, Sheffield and Lincolnshire, perhaps most sensibly, said it varied depending on how heavy the traffic was. So it's a case of taking your pick somewhere between 10 and 21 years. What I have done in this case is use a replacement rate of 6%, which actually gives an average life of 16 2/3 years per sleeper. Obviously, sleepers could be cascaded from mainline use to siding use to private line use. They were also used as fence posts second-hand, and they were also sold as firewood. So there is a slight recovery of outlay, but I think, again, as a round figure, a 6% recovery rate, a 6% replacement rate probably works reasonably well. Next slide, please. Then, again, a question which could no doubt be answered in a moment from a 20th century textbook: how much wood goes into a sleeper? The standard timber sleeper size, 9 foot long, 10 foot wide, 5 inches deep, seems to have settled into general usage by the 1880s. Before then, thinner section sleepers were used. And again, references to these tend to turn up in accident reports from the Railway Inspectorate when they say that this company is not using substantial enough sleepers. Some early companies used triangular sleepers, where you started off with a 13-inch square sleeper block, and instead of slicing it in half, you cut out 4 triangles from it. That again saved on timber. And a very few lines in Britain, far more say in North America, used half-round sleepers cut from logs which were usually specified as having a minimum diameter of 10 inches at one end and a maximum of 9 inches at one end and 10 inches at the other. I've worked out the cubic footage of each of those types of sleeper. What I've settled with is the familiar one from the 1880s, the 9 by 10 by 5, 9 foot by 10 inches by 5, which uses 3 1/8 cubic feet of timber. The relevance of that cubic measurement will become apparent in a moment. Next slide, please. You could say, if people are trying to be pernickety about this, what about stone blocks and broad gauge? Stone blocks were used by pre-locomotive railways. It soon became clear that they could not be used with locomotives because of their greater weight. And although you do get some pictures of sidings, for example, with stone blocks into the 1850s, they are statistically, I think, unimportant. Some companies, and I don't just mean broad gauge companies, some companies initially laid track on longitudinal supports. That obviously uses more timber than simply transverse sleepers. But that again doesn't last very long on standard gauge. It does last longer on broad gauge. And again, people will say, well, broad gauge sleepers must be longer than standard gauge sleepers. They must be. But despite the interest in the history of the broad gauge, by the 1860s, broad gauge track represents less than 8% of route mileage. And since that's probably less than the percentage error in this estimate, I've disregarded it. Next slide, please. So how much wood goes into a sleeper? Broad gauge track, which is disproportionately well documented, it must be said, in engineering institution proceedings, uses about 5 cubic feet of timber. Standard gauge track on longitudinal bearers use about 3 cubic feet. And as I said a moment ago, I've taken 3 1/8 cubic feet of timber as the average timber per sleeper, because if you multiply that rather irregular figure by 16, you end up with 50 cubic feet. And 50 cubic feet was the standard measure of timber in the timber industry until they switched to cubic meters. It was what was known technically in the industry as a load. The word load has a technical meaning in the timber industry until they switched to metrication in the 1960s. So I suspect most railway companies, if they were ordering enough timber for so many sleepers, after allowing for a bit of wastage, reckoned that they would need that a load of timber would produce 16 sleepers, possibly somewhat less with a bit of wastage. So that's the reason for taking that figure. Next slide, please. Now, if you take answers to those 5 variables which I've tried to work out, you can then estimate, and I say estimate, not measure. You can estimate the consumption of sleepers on British railways, which I've done here from 1840, the beginning really of mainline railways of any length, up to just before the First World War. I've separated the consumption into 2 categories, fairly obviously. One is the use of timber for sleepers on new lines, and the other is replacement timber. And I think the most striking result of this, admittedly fairly simple diagram, is to show that even by 1840, timber consumption, or sleeper consumption was over the 2 million mark. It goes up during the railway mania. The 1850 figure there reflects schemes promoted during the mania, which were still being built in around 1850. Thereafter, what I think is noticeable is there isn't an increasing consumption of timber for sleepers, as you might expect, as the network got bigger, nor is there a drop. If you take the view that once you put sleepers down, you could leave them there for years. You couldn't. They were definitely an item that was consumable rather than a fixed capital asset. But as far as I can see, consumption never went far above 2.5 million sleepers and is actually remarkably stable. So as the route mileage increases progressively more slowly, the consumption of sleepers for new track goes down. But as the network grows bigger, as single lines were doubled, double lines were quadrupled, more sidings, private branches were built, then the use of timber for replacement sleepers actually goes up. And the net result is produce a fairly stable picture between 1840 and the First World War that doesn't, as far as I can see, vary a great deal, between 2 and 2.5 million sleepers per year. Next slide, please. So, to sum up, by the 1860s, more sleepers were being used to maintain existing track and build new ones. And this meant that demand for timber continued after the network had been built. Whereas, for example, once you'd built a given number of stations out of brick, stone, tile, slate, then that expenditure stops. So sleeper timber is a consumable, not a one-off capital purchase. And if you convert the millions of sleepers into loads of timber, which is the measurement the timber industry would have used, IMechE about 150, 155,000 loads of timber, that is 50 cubic feet in each case, was used annually by railways in Britain between the 1840s and the First World War. Next slide, please. Now, the obvious next step with any study of the relationship between one industry and another is to ask yourself what proportion of total output does one industry's demand for the products of another industry represent? And this is where you hit something of a buffer, I'm afraid. The timber industry, despite its importance in the 19th century in Britain, is a very poorly documented industry. The structure of the industry is known in outline. What is lacking is very much in the way of statistics, and there is a complete lack of statistics of domestic production. The industry was divided conventionally into 4 groups: shippers, who actually shipped the timber from overseas, brokers, who arranged its sale once it reached Britain, importers, who were merchants who only handled foreign timber, and they didn't supply to consumers. They imported it, they didn't sell it to consumers. And then the merchants. Merchants could deal in either homegrown timber or imported timber, or both. And you might say, because the timber industry was one supplied very largely from imports in the 19th century, that's long been well known. Some people have quoted figures of 80 or 90% of timber consumed in Britain being imported. There is a tendency to assume in a rather mercantilist way that this was a bad thing. This misses the point, though, that all the branches of the timber trade contribute to the wealth of the country. The ships that brought the timber would have been largely part of the British merchant marine in the 19th century. The brokers and the importers were based in Britain, so of course were the merchants. So does the sleeper trade mainly benefit importers, or does it benefit merchants, or both? And was there a geographical concentration in the case of the sleeper industry? Well, next slide, please. Trying to work out where the railways got their timber is not impossible, but it's time consuming. It would be possible to read through the board minutes of every railway company and see where they placed orders. If you do that, not only would it take you more than a lifetime, you would probably come out with the result that the timber came from merchants. Railway companies did not own their own wood. They didn't import directly. They appear normally to have bought from merchants. So just using entries in company minute books wouldn't get you any further back than the merchant's name. What I've used instead, partly it must be said for economy of time, is to search newspapers electronically and look for advertisements asking for the supply of timber, tender advertisements, which I think are quite a good source for working out roughly where the timber comes from. One conclusion I've drawn from looking at about 20 years of newspaper advertisements spread widely across the country is that the earliest main lines, the ones built in the 1830s and the 1840s up to the railway mania of the mid-1840s, definitely used native softwood. Although it tends to be said that railway sleepers were made of imported timber, to begin with, the home market did respond, and particularly, as far as I can see, the timber industry in northeast Scotland, which is predominantly larch, also some oak. Also, railway companies in the south of England, the south of London companies, certainly tried to use timber from the New Forest or the Forest of Dean, as well as supplies from further north. Longitudinal timber was used mainly by countries on the western side of, companies on the western side of Britain, and seems normally to have been imported North American pine. If you look at imports, and again this comes from tender specifications particularly, overwhelmingly the timber is imported from the Baltic, chiefly Memel and Danzig, and then secondly from the maritime provinces of Canada, not so much the United States. They have plenty of timber, but they also have a very large home market for timber, and they don't seem to have exported it a great deal to Britain. But I think the main point is that although nowadays you tend to think of sleeper timber as being entirely imported, it wasn't in the early days. Next slide, please. You can see this also from looking at records of coastal shipping. There is definitely a growth of shipments from the ports of northeast Scotland, all the way down the east coast of Scotland, down as far as Leith, in fact, not just northeast Scotland, to the English east coast ports. And there is some increase in coastwise shipments between south coast ports as well. For example, from the southeast, which has relatively large quantities of timber, to the southwest that doesn't. And you can also see, particularly on the eastern side of the country, imported timber reaching its final destination by river and canal. It's one of the ironies of the relationship between canals and railways, is that although railways took away a great deal of trade from canals, canals enjoyed a brief spurt in the 1840s because they carried raw materials for railway construction to where the railways were being built. And this includes timber as well as iron and brick and stone. Next slide. So looking at tender advertisements, as you get the other side of the railway mania of the mid-1840s, there definitely seems to be an increased demand for imported timber. And not surprisingly, this divides into railway companies on the eastern side of Britain tend to specify Baltic timber. The Great Western Railway, some of the other railways on the west side of Britain suggest they would accept tenders for Canadian timber. I think the conclusion to be drawn from this is that domestic supplies didn't meet the whole of the demand during the railway mania. The supply of timber in the short term may be fairly elastic. Landowners may decide to increase the number of trees they fell each year, but in the longer term, the supply of timber is relatively inelastic because of the length of time it takes for timber to grow to the size that can meet a particular market, in this case, the railways. And the other event that occurs in the mid-1840s is the virtual abolition of the import duties on Baltic timber in the 1840s. After 1815, there was a very strong colonial preference in favour of Canada. So Canadian timber comes in very cheaply. Baltic timber was kept out by a high tariff. At about the time of the more famous repeal of the Corn Laws, which let in cheap grain into Britain, Sir Robert Peel also repealed the timber duties. And so from the 1840s, Baltic timber comes in very much more cheaply than it had done before. That isn't specifically done to help the railways, but it does in fact help the railways. Next slide, please. So by the 1860s, I would say most railway companies were using Baltic timber, except some on the western side of Britain, which may have used imported Canadian timber. And I think from odd snippets of information I've assembled, the Scottish railways may have continued to use homegrown timber simply because it was so near at hand. American and Canadian timber is then introduced during the First World War when trade with the Baltic is disrupted, and in the case of Hamburg, stops altogether. The use of Australian hardwoods, which people perhaps with experience of the railways in the 20th century will remember more clearly, the use of Australian hardwoods seems to be entirely a product of the post-1920 period. Next slide, please. I'll move on now to the second part of the talk, which is to say something about the connection between the timber industry, as used as it relates to the railways, the connection of the timber industry with the wood preservation industry, because this is a case, I think, where the railways generate indirectly a considerable increase in the demand for timber preservation. Attempts to preserve timber, mainly from the effects of water and insects living in the water, go back a long way before the railways. But right from the start, it was realised that sleepers lasted longer if they were treated by a preservative of some form. Various kinds of chemical preservative were tried. All the processes involve either soaking the timber in tanks or trying to press more preservative into the timber in enclosed cylinders under pressure. The first process that was tried on the railways, which turns out to be a dead end, is what was known as Chionizing, named after its Canadian developer, John Chion, which was patented in the 1830s. Next slide, please. This seemed like a good idea, but it fell victim, first of all, to the chemical problem that if chionized timber came into contact with iron, it rotted, which made it more or less useless for the railways. But also, Chion tried to expand very rapidly in Britain by working through a franchise system. And as newspaper reports said, some agents were much more efficient than others in how they operated the machinery. And gradually, railway companies came to realise that it was probably better to do their own preserving using their own plant. That remains the case after chionizing has been abandoned. Next slide, please. The process that eventually does become successful is the use of creosote. Creosote was first recognised as a separate product in 1834. The term is used, and perhaps unfortunately, for a vegetable-based material and also the coal tar derivative, which is what I'm actually talking about. It was produced initially as a byproduct of making gas from bituminous coal. The crucial early patent is John Bethel's of 1838. Unfortunately, because this was obviously a highly flammable process, his business never recovered from a disastrous fire in London soon afterwards. And the largest company in the business was what was called Burt, Bolton and Haywood, founded by Mr. Burt and Mr. Bolton in 1850, which becomes the largest creosoting business in Britain. And the company also integrates backwards into timber importing. They were a very large firm of timber importers till after the Second World War. Next slide, please. Creosoting was adopted steadily rather than rapidly by the railway companies. Some pointed out that railway sleepers wore out mechanically so quickly that it wasn't worth the extra cost of prolonging their life in a chemical sense. But by the 1880s, again, I'm relying here on the American Society of Engineers survey of British railway use of timber, creosoting was more or less standard. All the larger companies built their own works. Any textbook on this operation insists that outside suppliers could too easily adjust the quantity of creosote being put in the sleepers, and that for a satisfactory product, the railway companies should do their own creosoting. So most of the larger companies did erect their own creosote works. What's striking about these, and this again illustrates the fact that by this stage sleeper timber was being imported, was that nearly all these works are either at ports, or in the case of railway companies that didn't have any port terminals, they're on inland water, so that the timber arrives by water, but once it's been turned into creosoted sleepers, it leaves by rail. Next slide, please. The plant soon becomes very standardized. I'll show some pictures in a moment. The standard operation was to use a cylinder about 70 feet long, 6 foot diameter, which took one load of timber. The sleepers were pushed in on little bogies on a narrow gauge tramway. A vacuum was then created using a steam engine. The steam was also used to heat the creosote to make it go into the timber more easily. As you create the vacuum, the creosote is drawn up from a tank underneath the cylinder and is forced into the timber under pressure. Once the process has been complete, you then open the opposite end of the cylinder and draw a truckload of creosoted timber out. It's a relatively simple process. The crucial thing is creating an effective vacuum and using the right amount of creosote for a load of timber. And this was why received wisdom was that the railway companies should, wherever possible, do their own creosoting. Next slide, please. Some photographs now of one or two of these sleeper depots. This is the one closest to home at Beeston, just on the Nottingham side of the station at Beeston. And you can see there, I think, in the two open doors at the front of the building as we're looking at it, you can see the ends of two 70-foot tanks. And then on the siding on the left, there is a short line of tanker wagons bringing the creosote in. Next slide. Timber here being unloaded at the Great Western Railway's Hayes depot. The Great Western, although they obviously do have ports at the western end of their network, made most of their sleepers at Hayes in West London, where their main line comes very close to the Grand Union Canal. And so on the in the left-hand picture, you can see a barge bringing in sleeper timber. On the right, this is actually quite a well-known image because it looks so odd. You can look at a stack of sleeper blocks there waiting to be taken down and turned into sleepers. Next slide, please. This is from one of several photographs from Burt Bolton Haywood's Centenary History, published in 1950, showing a row of 3 creosoting cylinders, 2 of them with the door open there, and you can see the narrow gauge tramway going in, on which the sleepers were pushed on little bogie wagons. Next slide. This is their Newport, Monmouthshire works. There you can see on the left a load of sleepers about to be pushed into the tank. They were arranged so that you could pack as many sleepers as possible in, and that should be one 50-foot load of sleepers waiting to be creosoted. In this case, you've got tanks with the creosote erected above the cylinders. The creosote was then dropped down into a tank below the cylinder and drawn up by the vacuum. On the right, enormous piles of sleepers, either waiting to be treated or waiting to be shipped off onto the railways. Next slide, please. From West Hartlepool on the North Eastern Railway, same sort of picture. On the left, there's a man there breaking up the blocks of sleepers after they've come out of the creosoting process. On the left-hand side of the left-hand photograph, you can see a load just going into a tank. And then on the right, similar picture there of the yard with sleepers being loaded onto flat wagons. Next slide. Another picture of this is from Burt Bolton's Southampton yard, with a truckload of sleepers being pushed into the cylinder. It was not, I suspect, a particularly healthy occupation if you were standing there with creosote fumes all around you. Next slide, please. So, creosote and the railways. Let me again conclude with one or two estimates rather than exact figures. From various sources, I would say on average 2.5 gallons of creosote was used per sleeper. So if you're creosoting 2.5 million sleepers a year, you use 6.25 million gallons of creosote. In fact, the railways and indeed the independent creosoting companies would have used more than that, because some other types of railway timber, I've given 2 examples there, would also have been treated to make them last longer. And the post office also creosoted its timbers. There's a rather entertaining report of the discussion following a lecture, I think it's at the civils rather than mechanical engineers, talking about creosoting, and the surveyor to the post office stood up and said, I'm afraid Her Majesty's telegraph poles have been rather insulted in this lecture, so I want to make it clear that we also treat our telegraph poles with creosote as well, and they last a very long time. So let's say in round figures, about 7.5 million gallons of creosote was being used by the railways around 1900. Can you compare that with the total output of creosote? Next slide, please. Unfortunately, you can't, because creosote is one of those industries, again, not very well recorded. I've found one isolated figure that in 1890, output of UK creosote was the improbably precise quantity of 29.9 million gallons a year. Why it wasn't 30 million gallons, I'm not sure. If that figure is roughly right, the railways were then consuming about 1/4 of all the creosote produced in Britain. Official figures only start in 1907 with the first census production, by which time output was found to be nearly 70 million gallons. And if you use the figure I've got there for 1907, the railway's market share comes down to about 11%, which is obviously a lot less than 1/4. Next slide, please. The other figure that began to be collected after the first census of production was the quantity of creosote exported, mostly to the United States. And between 1908 and 1913, when the trade is disrupted by the First World War, exports were running at about 30 million gallons a year. So that leaves around 36 million gallons for domestic consumption. There are no imports of creosote, so that's the total quantity reaching the home market. That then raises the railway share back up to about 20%. Quite a lot of the exports may well have gone into railway sleepers, but in other countries. Next slide, please. You can in fact make rough estimates of creosote production going back to 1882, using figures for the quantity of coal used for gas making. Until 1882, there are very few figures for how coal was consumed in different markets. From 1882, there is an attempt to do this, and one of the industries which was counted was coal used for gas making. Again, using elementary textbooks, I've decided that a ton of coal produced about 11¼ gallons of tar, and 210 gallons of tar, the conventional measure of a ton of tar, produced about 27 gallons of creosote, a recovery rate of 12¾ Using those figures and taking the figures for gasworks tar in 1907, you get a figure of 13.3 million gallons of creosote. Next slide, please. Total creosote output as measured by the Census of Production in 1907 was, as I've said, 66.6 million gallons. If gasworks tar produced 13½ million gallons, 53.3 million gallons must have come from the other source of tar, which is coke oven tar. The first byproduct recovery coke ovens were built to serve the steel industry in 1882. And so I've estimated the total output of creosote made from coke oven tar as a residual by working from the figure which I've actually got, the real figure, for creosote made from gasworks tar. Go to the next slide, please. And so again, you can produce a simple diagram which shows that gas tar creosote doesn't go up a great deal in quantity from 1882 up to the First World War. The real growth of the supply of creosote to the market comes from coke oven tar, that is, coke ovens of the more sophisticated sort, the recovered byproducts that are introduced in 1882 and then spread very rapidly through the steel industry and to some extent independently as well. But by and large, this coke ovens were producing for the steel industry. And that gets you up to a figure of about 70-odd million gallons of creosote in total made just before the First World War. Next slide, please. So if you then estimate the amount of creosote used by sleepers, starting from my figure of around 2.5 million sleepers a year being produced, then you can see, in fact, the railways are a small and declining market for the creosote industry. The real expansion comes from other markets, and as the short series of export figures for the period up to the First World War shows, a very large part, quite a large part of the total output of creosote went overseas. If you take out overseas consumption, then the railway's percentage share of the market is rather larger. But again, I think the important point to stress is that this is a new market. And so I suspect one of the reasons why creosote production increased so much in the 19th century was because it was used by the railways to preserve sleepers. Next slide, please. So coming to some conclusions, stressing always, as with any kind of 19th century economic history, that you can really be precise. The railways become major consumers of timber between about 1840 and the First World War. And during that period, the railways probably used about 2.5 million sleepers a year. Demand initially fell on both homegrown and imported timber, but by the middle of this period, probably the timber was coming almost entirely from the Baltic, to a small extent from North America. Next slide, please. You can't relate sales of timber to total timber sales because there are absolutely no figures for domestic timber production. It's as simple as that. They're not going to jump out of the woodwork. Excuse the pun. It is one of those industries where there was no attempt to measure output until I think it's the 1950s, in fact. But what you can say is that annual sales of timber for sleepers must have been around 150, 155,000 loads. It is possible to extract or to compile a series of figures for imports of timber. I haven't as yet done that. It's something I'd like to work on further. It's not straightforward because timber arrives in Britain in a variety of different forms, mostly measured in loads. Hardwood tend to be measured in tons. And the only existing history of the timber industry effectively throws up its hands in despair and says you can't produce any series from this data. I think you can, but I've not yet done it. But when you also add in other types of railway consumption of timber, as one example I gave at the beginning, rolling stock, buildings, line-side equipment of different sorts, then it seems to me that the railways do represent a considerable market for timber in this period. Next slide, please. It's the last one. Yes, the last one concerns Creosote. The point I'd also make is that the railway demand for timber is almost entirely a new market. There are railways before 1840 that did use some timber, for example, for wagons, but it's a tiny quantity. And then if you go one stage further on and look at the consumption of creosote, it's a falling proportion of total sales of creosote, but it's a relatively important element in home sales. It may be the biggest single home market for the creosote industry. It's difficult to know how to work that out. But what I would say is that creosote and also tar making are two industries which grow from virtually nothing, in the case of the creosote industry completely from nothing, in the 19th century. They've been sadly neglected. When I started this work, I searched various bibliographical databases for references to creosote. There is no history of the creosote industry. That's perhaps not surprising, but there isn't one. And so this is one of these cases, I think, where you can start off with a very familiar story, which is the history of railways in the 19th century, look behind the railways themselves at some of the industries whose growth they stimulated, the industries for which they provided a new market. And not only does this include timber, very obviously, but also if you go a bit further on, you can see that that it became worth distilling creosote from tar or from as a byproduct from coke ovens because there was this new market for the railways. So yet again, you come back to the general textbook conclusion that the railways transformed the economy of mid and late 19th century Britain in almost every way you can imagine. Thank you.
Philip, thank you very much. Apologies, one of the things I meant to mention at the start of the presentation was that if you have any questions for Philip, can you please use the chat facility, and what will happen is I'll read the question out and then Philip will answer it. So if you could just take a moment to use the chat facility on Zoom, and then I will look at the chats and look at the questions, and then obviously from there on we can then ask any questions that we can ask any questions of Philip as they come in. Okay, great talk from Liz. Thank you, Liz. So have we got any questions for Philip, please? I'm sure they'll come through in a moment. Question from Tim Stubbs. How long did it take to creosote a load of sleepers?
I think it's a matter of some hours. I think it's about 6 or 8 hours. Again, textbooks on this process warned against outside contractors who said they could do it for a shorter time. You did have to warm the cylinder up to create a vacuum, warm the cylinder up to draw the creosote up from a semi-liquid state, and then make sure it was properly pressed into the sleeper. So it's not just a drive-through process. It's probably one shift of the team's work to do a load of sleepers.
Okay, so quite a few questions are now coming through. What proportion of renewal cost did re-sleepering represent, if there is such a word? Replacement of sleepers, I think, is that.
Sorry, I mean, I don't know what the labour cost is of re-sleeping a mile of track. What was the, sorry,
What proportion of renewal cost did re-sleepering represent? Is the question.
Of renewing a mile of track, say, something like that?
I would imagine you'd have
Yes,
to do it.
I don't know, because I can't quote any figures for the cost of the rails.
Right.
No, I don't know. I mean, I haven't as yet worked out a price series for individual sleepers. So no, sorry, I can't actually answer that question. There probably is an answer somewhere in a paper in either the civils or the mechanicals proceedings in the 19th century, but I haven't come across it.
Okay, next question from Tim Stubbs. What was the lifespan of, I presume, of creosotes? So I presume that's probably a creosoted sleeper.
Yes, this is the one, as I say, the American Society of Engineers did a large-scale survey in the 1880s, published in their proceedings. And as I said in the talk, they found quite a wide variety of experience. And I think probably the most sensible response to the questionnaire was the Manchester, Sheffield, Lincolnshire company saying it could vary by a factor of 2 to 1, ratio of 2 to 1, as between, say, the station throat at a big urban junction, big town station, and a rural line, which only saw about half a dozen trains a day. It seems to be between 10 and 20 years in the reckoning of most railway companies.
Excellent. Okay, thank you.
And the residual value, I seem to remember from this paper, they were quoting something like 4p a sleeper to sell them for firewood, that kind of thing. There isn't a great deal of resale value. I believe British Railways used to pass sleepers onto the coal board and those sort of customers to use on internal user lines, but they don't have much second-hand value.
Okay. Question from Colin. Do you know how many people were involved in sleeper production?
No, I don't. There are no. The case of those who were employed by railway companies, you couldn't separate them out from the number of employees the company had. You might find in railway company records some indication of how many people their sleeper works employed. That wouldn't include obviously track laying men who actually laid the sleepers. I'm fairly certain there are no separate figures for the number of employees of independent companies. Burt Bolton and Haywood, for example, as I said, when it ended up as a vertically integrated company, they did do sleeper creosoting and sleeper production, but they were also timber importers. So their total employment figures wouldn't really help. So no, I'm sorry, the answer is I don't know, because it's not an independent industry.
Okay. Thank you, Philip. Next question is from Arthur. I'll read it as it's stated, but you can take it as it comes. As a child of the 50s, I remember nearly all wooden sleepers on SR, presumably Southern Railway. So could you extrapolate these figures through that period?
I can't. I deliberately stopped at around 1910 because it's when the route mileage of the railways reaches its greatest extent. I mean, curiously, when I've given this talk before, one or two people have said, didn't the Southern Railway switch to using concrete earlier than most people? Because they certainly pioneered concrete for buildings, for instance. I've tried without very much success to work out what the progress of the concrete sleeper is. I must say the Permanent Way Institution have been extremely helpful with supplying copies of articles in their journal, but there don't seem to be any comparative figures as to how many miles of railway had wooden sleepers, how many had concrete sleepers. So I don't know how many sleepers the nationalised industry used. I don't think the industry changes a great deal. I think companies continue to produce their own sleepers from imported timber. And if you read Burt Bolton and Haywood's centenary history, they see sleepers as a declining market since the railways were nationalised, because the nationalised industry would produce its own. But no, sorry, I can't. It's possible the railways collect the figures for their own use, but I don't think they're published anywhere.
Okay. Next question from Matthew. What proportion of the track is currently wooden sleepers, and are they being still renewed with wood?
Again, I suspect members of the audience will know much more about this than I do. My understanding is that points and crossings are still sleepered with timber because it's more flexible. But I thought all main line track was now sleepered with concrete. And I know you see sidings still with wooden sleepers, but I suspect those aren't renewed very often because I don't see that much traffic these days. So I assume there is still a small demand for wooden sleeper timber for points and crossings. But as I'm sure there's somebody in the audience who knows more about this than I do.
Okay. Okay, next question from George. Where does railway timber use rank with other industries such as mining?
Again, I don't know. The mining industry is another big user of timber in the 19th century. In fact, it's a big user principally of Baltic imported timber. I did try to compare this. I can't find any figures for how much timber goes into collieries, but it's a considerable amount for roof supports. Modern hydraulic roof supports came in quite late, right up to nationalisation in the coal industry. The industry was using very large quantities of timber. Indeed, as a student, I had a job in the National Coal Board's North Derbyshire area office, and in the finance department, and I can remember going through piles of invoices from timber importers in East Anglia who supplied pit props to the board in Derbyshire. So it remained a big industry. The biggest single market for timber in the 19th century, I'm quite certain, is building. The problem is how much timber goes into a 19th century house. And that's, again, I don't think there's any contemporary data for that. But it's in round figures, it's a lot. So I think possibly where the railways are important is as a source of marginal demand. It's a new market. Houses had always used timber. Okay, there are more houses built in the 19th century, but houses had always used timber. Collieries had always used timber. Other industries had always used timber. The railways are a new market.
Okay. A lot of people saying what a great talk, so thank you, Philip. Next one's an observation from Andrew Thornton. All this discussion of gas coat works and sleeper works gives plenty of work for modern day contaminated land specialists.
Yes.
No doubt. Okay.
Yes, well, again, some personal reminiscence. I grew up opposite Avenue Carbonisation Plant in Wingleworth, near Chesterfield. Subsequently claimed to be the second most contaminated site certainly in the Midlands after Colite in Bolsover. So yes, it was a very contaminating industry.
Okay, a few more questions. When and why was creosote abandoned, and what is now used in its place?
As I understand it, I went into this a bit, the idea that you can no longer use creosote is an urban myth. What you can't do is buy it retail to paint your fence with. It is still produced, and it can still be used in an industrial setting with very careful safeguards. I'm not sure, I'm afraid, what is used in its place, but I think it is still used as a timber preservative in an industrial setting. It's just that you mustn't use it at home anymore.
Okay. Next question from Tim Stubbs. Was the job of a creosoter regarded as attractive compared with other railway employment or, say, in the mining industry?
I can't imagine it was very attractive. Again, I don't know what the sort of health consequences are, but being exposed day after day to fumes from these cylinders as the doors were opened and the newly creosoted timber came out can't have been healthy. I mean, whole areas, obviously, of industrial employment were not very attractive by modern standards. But yes, I would have thought creosoting was not a particularly attractive, say, side of railway work compared with other kinds of manual grade work. And certainly working in coke oven plants wasn't very healthy either.
No. I can imagine you smelt well, but I don't think it did much for your health.
Well, no, I don't think it does. I mean, again, this comes through to the modern coke industry. Avenue plant was not regarded as a terribly healthy place to work in my childhood.
Okay, next question. Interesting insight, thank you. Having seen recent developments of crossing profiles, the stock loading has been reduced and concrete sleepers is now being used for point work. So an observation from Jeff Ward. Question from Martin Elliott. Are there any economic advantages to using hardwood, expensive, versus softwood, cheaper?
Yes, I don't know. As I understand it, the hardwood that's been mostly used for sleepers is Australian jarrah. I don't think much African or Asian timber was ever used for sleepers. I think the problem would probably go back to the same comments that were made in the 19th century, that sleepers wore out mechanically before the preservative had any real advantage. It's possible that because sleepers had to replace fairly frequently, there was no real gain in trying to use hardwood sleepers. They would still wear out. But I don't know the details. What you don't get in Britain, of course, is the threat from insects, which is an incentive to use hardwoods, I think, in Australia.
Okay, and I think for now, for today, the last question from Andrew Thornton. Do you have any comments on the volume of felled timber that was actually used for practical purposes?
Not really. As I've said, I think early fellings seem, in Britain anyway, seem to have been predominantly from northeast Scotland, and to a smaller extent, the southern English forests. Thereafter, the railways, like most other consumers of timber, most used imported timber, and that timber comes from countries in Northern Europe, which have obviously not exactly an infinite supply of timber, but far more timber than we do. This is a matter that goes back, say, to the 18th century iron industry, where it wasn't rational for Britain to produce more iron using charcoal because we hadn't got enough land to grow enough timber. It is rational to import timber in the 19th century from Northern Europe because they have got plenty of land to use for timber that isn't suitable for much else.
Excellent.
And as I said in the talk, it's wrong to imagine that imports, this old mercantilist idea, exports good, imports bad, because the import trade in timber does generate considerable employment and profits for British industry.
Okay. So thank you for that. Martin Elliott, I've unmuted your mic. So Martin is going to give the vote of thanks from both the Institution of Mechanical Engineers and on behalf of the Derby Railway Engineering Society. So Martin, over to you, please.
Thank you very much, Mark, and thank you, Philip, for a fascinating insight and fascinating presentation tonight. As Mark said, I'm from the IMechE Midlands Centre of the Railway Division. Unfortunately, our chair, Jason Greenbridge, isn't able to join us tonight. I'm the secretary. So it's fallen upon me to thank, firstly, I'd like to thank DRES, Derby Railway Engineering Society, for arranging this lecture. Once a year, we have a joint event between the IMechE Railway Division and the Derby Railway Engineering Society, and this is obviously tonight's event. So thank you for organising it, and thanks for running the Zoom call, which I think has worked very well. Clearly, Philip, I'd like to thank you in particular for the presentation, a fascinating presentation that's taken us through the use of timber in general in the industry, and obviously then majored on the use in timber for sleepers. And also clearly then talking about the preservation of sleepers. As a mechanical engineer, sleepers and timber we don't generally tend to think about, so it's really been a useful insight for mechanical engineers to think about timber and sleepers and what an important role they've had in the rail industry. I must say, when I joined the rail industry, which was in the late 1980s, it was just after the King's Cross fire, and of course, clearly London Underground used a lot of timber for things like escalators, for instance, were still timber back in those days. And one of the first rolling stock projects I worked on was replacing the timber floors in their C-stock, central line stock vehicles. And that was done at Doncaster Works, and I know a lot of people in Doncaster ended up having sheds, dog kennels and things that were made out of the timber that was taken out of the floors of those vehicles. So yeah, clearly timber has had a big, well, timber and the rail industry have gone hand in hand for many years. And I really think your talk brought that out, and certainly the numbers were just amazing, the sort of volume of timber that's been used, and the fact that it's not just when the railways were built, it's clearly the ongoing maintenance and renewal of sleepers. So an absolutely fascinating talk and very well presented, and the slides were excellent, the pictures were excellent as well, so thank you very much. So thank you very much, Philip, for this evening, and thank you very much for DRES for hosting it. And I hope that our joint event next year we're able to have in person rather than via Zoom. So that's it for me. Thank you very much. And
thank you, Martin.
Back to you, Mark.
Thanks very much for exceptionally well-informed questions, which have made me think about a number of other aspects of the subject. I'm only sorry I couldn't see everybody in person to talk to about this.
Indeed.
Because you are railway professionals. I'm not.
Thank you, Philip. One last thing then. Colin, would you like to say any final words for this evening? I've opened your mic.
Yeah, thank you. So again, I think a very interesting lecture. I mean, I wasn't quite sure where it would go with the subject matter, but really quite thought-provoking. I'd not really considered the scale of use of Creosote, particularly in the rail industry. So very interesting. And again, thank you very much for a really good talk and a really good set of slides, which got the point across really well. So I think just on that, so our next lecture from Dres will be the 21st of January next year. So it'll be titled Level Crossings, the Most Significant Risk on the Railway. And that will be presented by Andrew Allen from Aegis.
Excellent. Okay.
Mark, if I may, the next IMechE Railway Division Midland Centre event is on the 13th of January, and that's about the Class 769 Flex project, and that will be presented by Porterbrook. So again, DRES members and anyone if anybody is free to attend the IMechE lectures.
That's brilliant. Thank you, Martin. Okay, so it's only now for me to say once again, thank you to Philip. Fascinating lecture. Thank you to everybody who's attended. We've had a really good attendance. About over 50 people have attended today, which has been excellent. I'll stop recording this session in a moment. A copy of the video will be uploaded onto the DRES website in the next 24 hours. And all it is left for me to say is to say thank you. I'd like to wish everybody Merry Christmas and a Happy New Year. And let's hope that 2021 is a lot healthier and safer for all of us now the vaccine has been developed and approved. So on that note, I'd just like to say thank you and good night.
Good night. Good night.
Thank you.
Good night, everybody.
Good night.
Thank you, Philip. Bye-bye.
Thanks, Philip. Thanks for the lecture.